All right, so now we got the cost up here. Do you see that we could have done this, never mind, I won't say anything about that. So we got our variables defined, G, S, and C. Now we gotta set up our equations, right? So the equations typically, and where do we look, before I move on, where do we typically look to find what the variables are? There's almost a cheat when you're doing word problems. Where do you look to find out what the variables or the unknowns are? Yeah, the question, right? Find the cost of each type of ticket. So whatever you're trying to do, right, that's what makes this an algebra question, is you gotta find something that's not known. So those are typically the unknowns, right? So that typically comes from the question or the statement of the problem, right? Let me make a note of that. So that's gonna always be. So look at the question being asked. Now, what about the equations? Usually, the equations are going to be set up pretty logically, right, in this. I mean, they sort of make sense. They're going to flow with the problem. We're given, like, usually, like, it's almost always like one sentence per equation, usually. It doesn't always work that way, but a lot of times it does. So what about this one? Mark bought 9 general admission, 2 senior citizens, and 3 children's tickets and paid $170. So that's equation 1. What's that going to look like? 9G plus 2S, good, plus 3C equals 170, good. And then we've got Sarah bought 5 general, 4 senior, 7 child, and paid 173. So that's what, 5G. Good, and then finally, we got Kyle, 4, 1, and 6. So, what, 4G plus 1S, I didn't put the 1 there, did I? Plus 6C equals 0.5, okay? And there's our system, right? Okay, and then, maybe we don't even need to take the time to solve this. Really, the big thing is just setting it up. The problem's not going to be any harder than anything we just did. What would probably be, I guess we could at least maybe identify, what do you think would probably be the easiest variable to eliminate? Probably S, wouldn't it, right? I could take these two, or I could take, I could take these two, couldn't I, and multiply the top one by -2. I could take the bottom two and multiply the bottom one by -4, maybe, something like that, right? Make sense? Okay, and we could go from there. Do we want to finish this, or do we want to just?
Finish it.
Okay, we can, that's fine, we can finish it. So there's our setup. Now, we said we'd do, these two would be group A. And didn't we say these two were going to be group B? Which ones? Oh, might as well do these two, huh? That'd be even easier. Right? That'd be good. That's group B. So if we do group A, then we've got 9G plus 2S plus 3C equals 170, and 5G plus 4S plus 7C equals 173. Okay? Just kind of split this down the middle. And then group B, 9G plus 2S plus 3C equals 170 in the bottom one. 4G plus S plus 6C equals 116.5. So going back to group A then, or system A, what are we going to multiply by?
-2.
Top one by -2. Okay. And that's going to give us -18G minus 4S, what, minus 6C equals -340? Okay. So got rid of the S's. Gotta do the same thing over here, remember? When we add those up, I'm gonna get, you help me out here, what's that gonna be? Negative 13G plus C equals 167, negative 167. Okay, so there's what we get from the first system. Second one, what are we gonna multiply by? Bottom by -2. Okay, and that gives us 9G plus 2S plus 3C equals 170. On the bottom, we're gonna get negative 8G plus, whoops, minus 2S minus 12C equals negative 233. Is that right? I add those up. S is canceled, that's good. We get G minus 9C, so far so good, equals negative 63. Is that right?
No.
Okay. And so now we've got our 2x2 system that we can solve. Negative 13G plus C equals negative 167. You know what I'm gonna do? Let me do this, save a little space here. Let's start. We'll do that. So we get negative 13G plus C equals negative 167, and G minus 9C equals negative 63. What's the easiest way to get rid of a variable there? Top by 9?
Yeah.
Everybody agree? Okay. So if we multiply top equation, we distribute a 9 through, then we're going to get the system, well, that's going to be big stuff. So negative 117, G plus 9C equals, oh goodness, what's that going to be? So we throw that in your phone or something real quick. I don't want to think that hard right now. What do we need to get? 9,000 what? Negative 1,530. Okay.
No, zero.
Oh, 0.3, whoops. There we go, okay. And then on the bottom, we get our G minus 9C equals negative 63. So if we add those up, C's go away, we're gonna get some big coefficients. So I get negative 116G equals negative 1566.
Yep.
But G's gonna have to be an integer, isn't
I
it?
got one.
I got
one. Yeah, one.
Oh,
Uh-oh.
oh, wait.
Oh,
you're-
oh, for the negative.
Yeah,
one.
it's a negative.
Oh,
Okay, so that's gonna be, what's that gonna be?
13.5.
Okay, we got a problem there. Can't be 13.5. How come? What does it represent? Oh, no, it can't, it's cost.
Yeah, it's total cost. There you go.
I was thinking it was number of tickets. No, it's fine. 13.5, so G equals 13.5, so it's $13.50. That's fine, isn't it, right? Okay. So if G is 13.5, let's go back to where?
The
Probably
G minus 9C.
Bottom one, yeah, that'd be easier, wouldn't it? So we'll go there. So then if we plug that in, we're gonna get 13.5 minus 9C equals negative 63. So what do we gotta do? We gotta subtract 13.5. So that's gonna give me negative 76.5, and if I divide by negative 9, what's that give us? Right. Say it again?
Or 8.
8.5. So C is 8.5. Okay, $8.50 for a child ticket, it looks like. And then we'll plug both of those back in. What's the easiest original one? Probably the bottom, I guess?
Yeah.
Seem good?
Yeah.
So if we go into the bottom one, we're gonna get 4 times 13.5, right?
Yeah.
Plus S plus 6 times 8.5 equals, I'm running out of space here, 116.5. So that's gonna give us 54 plus S plus 51 equals 116.5, so we're gonna get S equals 11. There we go. How about that? Okay, hold it, not 11. 11.5. Yeah, right, because we're gonna get, yeah, 11.5. So we got our 3 values, didn't we? So our ordered triple then, man, we're running out of space here, aren't we? So our ordered triple is gonna look like, what came first? We had G first, so it was 13.5, then we had S, which was 11.5, and then we had 8.5 for C, and that's gotta be in the form G, S, C, right? But for this example, I mean, in an application, do we wanna write it as an ordered triple? No, we wanna know what the amounts are, right, what the costs are of the tickets. Okay? Whew, that's a lot of work for one problem, isn't it? Yep. Okay, so what about something like this then? Let's not do this whole thing, let's just practice setting it up. That we'll get a little practice with that. So what are the unknowns here? What are the things we're trying to find?
Nickels, dimes, and quarters.
Nickels,
The
dimes, and
number.
quarters. Okay, so we can just call those N, D, and Q maybe?
Yeah.
How many of them? Good. Okay, so we've got N equals number of nickels, D equals number of dimes, and Q equals number of quarters. So there's our variables. Now let's set up some equations. So Jamie has a collection of 78 nickels, dimes, and quarters worth $12.40. So what's that gonna be? 70, right. Yep, yep. So maybe there's even 2 equations there. Maybe 2 equations, aren't there? Right. So what's the first equation? Let's, okay. Yeah, she has 78, and these are the numbers of each one.
Oh, so you have to split it.
There you go, right? So the number, the sum of each of those, because those are just the numbers of each kinds of coins,
And
their sum must be 178 then, right? The numbers, the combination of the numbers of each kind, the sum of the numbers of each kind must be 178. So equation 1 is just gonna be N plus D plus Q
178.
equals 78, sorry. Okay, now what about equation 2? Well, it tells us something else here, right? It tells us that the value of all that stuff is 1240.
So, that be another.
Okay, so how am I gonna set that one up? So, okay, so 0.05 N plus 0.1 D plus 0.25 Q must equal 12.4, right? That make sense? Because doesn't this represent the total value of all her nickels? She's got in nickels, right? That's the total value of all her dimes. That's the total value of all her quarters, and they must add up to 1240. Okay, last, everybody good with that? Okay, last equation, if the number of quarters is doubled, the value becomes 2215.
So you just do the same thing. Yeah.
So that's gonna be kind of tricky then, right? So it's gonna be, if we just doubled the number of quarters that she had, that's what the value would become. So what happens to equation 2 then?
It's the same as above the second.
Okay, we got the same number of nickels, so the value of the nickels is the same. We get the same number of dimes, but we're gonna multiply 0.25 times what? 2Q, right? If we double the number of quarters from Q to 2Q, it changes the value of the collection to 22.15, right? And so, I mean, we could simplify that. What is 0.25 times 2 is just 0.5, right? So we'd probably want to rewrite equation 3. We'd want to rewrite equation 3 as just 0.05n plus 0.1d plus 0.5q equals 22.15, right? So that would be the way we just simplified version of equation 3. But then I've got my 3 equations, 3 unknowns, and I can solve that system, right? Make sense?
Yeah.
Okay. I debated whether I should do this, but I'm going to show you. Okay, I'm going to show you a really good trick for solving this stuff. Okay, so I'm not going to probably have you do this on the test, but I just want to show this to you. You can check your work this way. Now, this does require your actual graphing calculator, so you got to bust out your TI-84. There's a pretty cool way to do this stuff. So while you're getting that thing out, I'm going to rewrite this system so we can see it just in one place here. So we get. Did I say that?
Do you want to share your like that too?
No, you don't need to. Okay, so here's what you can do now. This is really cool. This is using a matrix method. Okay, I'll just say a word about that. So as you move forward in math, and I'm hoping all of you are going to your trajectory is like you're going to keep taking math classes. Eventually you're going to take a class in college. This wouldn't really be a high school topic so much, but in college you'll take a class called linear algebra. Right? A lot of times you might be called linear algebra and matrix theory or something like that. So what that's about dealing with this exact topic that we're talking about. How do you grapple with large linear systems? How can you solve them efficiently using a technique called matrix math, right? And a matrix is something, maybe at the end of the year we'll come back and we'll talk more about matrices and how they work a little bit. But I don't want to take too much time now just because it's not really a part of our Algebra 2 curriculum. And we'll kind of plug it in at the end, I think. But here's what you can do with this. For now, I'm just going to show you the trick. We'll come back and dissect this trick later. But if you pull up your calculator, and gosh, where's mine? Okay, this may come to an abrupt halt because I don't see, I'm not seeing my calculator where it's supposed to be. Ah, there it is. Okay. Here's my fancy calculator. Okay, here's what you do. Here's what you do. That's what yours looks like, right?
Sure.
So we're going to go to you gotta kinda just follow these steps. We're gonna go to the matrix feature, which is, it's behind the exponential, or the inverse function there. So we hit second, and then that button right there takes us to matrix. Takes us to the matrix menu. Okay, and that's the matrix menu on the TI-84,
I'm already lost.
or the matrix screen. Well, you just hit second and then push that button right there.
Mine already has it. I already pressed it. How do I fix that?
You just go to edit.
By the
Right,
way-
so you may be doing some stuff in chemistry, and this might actually help some things you do maybe in chem class later in the year. So then when you get into the matrix screen, there are three menus. Let's just make sure you understand how this works. There's the names menu. This is where you define these matrices and you can use them. You may have some defined from chemistry. I don't have any, that's okay. The next menu over is the matrix math menu, where you can do all kinds of fancy matrix. You can do some matrix algebra in your calculator. We're going to use one feature from that, and that's it, but I'll get there in a second. And then far to the right is the edit menu. The edit menu is how you build a matrix. So if you're in chemistry, you're familiar with this one, right? So we want to build a matrix. I'm going to build matrix A. I'm going to go ahead and select that. I'm going to edit matrix A, and we're going to put this system into matrix A. Now here's how we're going to set this up. We're going to have one column for the first coefficient. So whatever, and we have to write these equations in standard form now. We have to write them in the form where we're going to put all of the n terms come first, and then the d terms, and then the q terms, and then we put equals the number on the right side. You see that this is related to what we did earlier in the unit when we did something like ax plus by equals c, right? Look, we had the x term first, then the y term, and then we had the constant, the number on the other side. Well, what if we were doing that in 3 dimensions? All we would do is we would just say something like ax plus by plus cz equals d, right? I mean, we could do that with x, y, and z. We just extend the equation by 1, right? Well, we're not using x, y's, and z's. We're using n's, d's, and q's. Doesn't matter. That's fine. As long as we use the same order for all the equations, that's standard form, okay? So they have to be in standard form. We're going to have one row of our matrix. A matrix is just going to be, like an organized, it's going to look kind of like a grid. You're going to have some rows and some columns, right? You're going to have one column for each of the coefficients of n. You're going to have a column for the coefficients of d, a column for the coefficients of q, and then a fourth column for the constants. You're going to have one row per equation. So what that means is our matrix is going to have 3 rows and 4 columns. So we would call that a 3 by 4 matrix. And it builds us, look, it builds us a template for a 3 by 4 matrix. Okay? So then all we have to do is just put in, what do you think I'm going to put there? 1, because it's the coefficient of n, so it's going to be a 1. What's going to go there? What's going to go there? And what's going to go there? 78. Everybody see that? That means that first equation. 1 times n plus 1 times d plus 1 times q equals 78. What goes there?
Oh, shoot.
Pick it up tomorrow.
I didn't even know that.